Hello everyone, and welcome to a quick demo of Engage K12, the online learning portal from RobotLAB, which covers basically every grade, every subject, and every robot. In this quick demo, we'll show you three lessons, three activities that you can use in your classrooms with your teams, and one will be for high school algebra, the one that we have you'll have in a second on your screen. The second one is for elementary level, more around the geometry and angles. And the third one is in for middle school for basically time distance graphs. So we'll start with this one. This is for a high school level, linear equations. And as you can see, every lesson starts with a quick introduction about what's the lesson, what we are covering, which standards we cover for this specific lesson, and basically everything that the teachers need in order to know how to run this lesson. Every lesson is broken down to basically four pieces. And we start with observation. We want to spark the user's curiosity. So we want to hook them. We want to use their creativity and curiosity and basically try to trigger some interest in the subject that we are teaching. So in this case, we are going to show them a video of the now robots playing soccer. And by doing that, they actually follow the ball, they kick the ball to the goal, they know how to triangulate themselves and the ball and the goal and everything. And we ask the students, what do you wonder? What do you want to know? What do you need to know in order to make these robots play soccer? And there is no right or wrong answer. We let the students submit their answers from the privacy of their keyboard. And this allows every student to participate, so they don't need to be, shy. Many students don't feel like they want to raise their hand in the classroom because they might have a wrong answer. There is no right or wrong answer. Everyone can participate, and the important thing is that the teacher can actually see what's going on here, where the class is, what the majority thinks. But the teacher also gets the preview into, not the insight into each student's response. And what we're doing here, and you'll see that across all the lessons, this is something that is very powerful with robots, with robotics in general. Robots are non-judgmental, and they don't care if we make a mistake, if we are right or wrong. And we want to use the same notion, the same feeling, that it's safe, that it's not judgmental, no one is going to tell us we are wrong and embarrass us in front of our friends. We want to use the same flow here on the lesson. So we ask the students just to type in on their keyboard, and then everyone can see the result of that. The result of the class, not their own personal thought. When we're done with that, with this initial phase, we got their curiosity. Now we ask them to put their emotion, their kind of commitment into that. So we ask them, without knowing anything about linear equations, that's a linear equations lesson. So without knowing anything about linear equations, you just need to know that a line that goes up on the xy plane means positive slope, and a line that goes down means negative slope. That's the only thing. So looking at the data points here, these are basically the points on the grid. We ask you, what do you think? Just estimate. What do you think is the slope? Is it a positive slope? Is it a negative slope? And again, we let the students type in their answers from the privacy of their keyboard without any fear of embarrassment or something like that. And there is no right or wrong answer because, again, we don't know anything yet. We just started to work on this activity. And once they submit that, Then we take them to the next step, which is basically the fun part. So we start with a graphing calculator. So here's the plane as we saw it earlier. So that's the goal line, okay, the blue one, and that's the line that the ball travels on. And this is a slope. If someone didn't get it so far, that's actually the slope or the path that the ball will follow on the way to the goal. Now, as a teacher, you can actually move the point. You can tell the student, I want the ball to hit that point or that point. So figure out what's the equation of the line that will actually go through this point. So based on 5, 0 and 8, comma 2. Now, if you don't know how to solve it, and again, we don't take the teaching from the teacher, we just augment them. If you don't know, as a student, if you don't know how to teach it, here is a hint that will actually help you to solve this equation and figure out what's the slope here. Now, once you're done with that, we want you to actually test your assumption. So here is an equation which is already pre-populated with everything. You just need to put in the slope, and then let's basically run the simulation and see for ourselves. They can actually see it from different angles. Let's see the robot turning over here. Okay, and kicking the ball to the goal, and we have a goal. Good, so they can actually see for themselves if this slope that they came up with, if this is right or wrong. And this is an important piece of everything, because we want the students to be able to work with the robots even if they are not next to the physical robot. We want them to be able to use it as a homework, or in flipped classroom, or in small groups, work together and figure out what's going on here, and later on get access to the real robot. So this simulation tool, which is available for every lesson, for every activity, is an integral part of Engage K12, and it's something which is very important in the whole experience. And once they are done with that, then we can connect to the real robot. We can put our name and just like what's the stuff that we think, and do the robot, basically make the real robot walk over and run the soccer simulation based on the slope that we assume. Now we want the students to put stickers on the floor and want them to measure the distances and everything. There are on the teacher side, there are a lot of instructions on how to do that and what's the ratios and distances and everything that we expect, that the robot expects. Now, the important piece here, you actually control the robot directly from a browser. Any Chrome browser, including Chromebooks, can do that. And this is something very powerful, because you make a humanoid robot walk, you stand up, walk, and kick the ball from your browser with zero coding, zero programming. You don't need any experience in robotics and all of that. You just need to know math, and to know what's the slope, and just run it. At the end of the lesson, we take them again to a summary in which we ask them, so what have you learned today? And everyone can just like check what they know today. And this again gives the teacher the ability to understand what the students think they mastered today, and which areas he will need or she will need to focus on later on. And at the end, the students can download a copy of their worksheet, including what happened in the classroom, which is basically everything that we went through over here. So this is really quickly a lesson for high school with linear equations, basically Algebra 1 lesson. Let's jump to another lesson more on the elementary level, in which we show the students basically a dance, and we want them to make the robot to be a cheerleader of our soccer team. So in order to be a cheerleader, the robots need to dance. And let's say they need to raise the roof. So how do they do that? So again, we show them a video of the robot actually in a dance move, and then we ask them, what do you wonder? What do you want to know? Okay, and then we let them just like before, we let them type in their answers. Okay, how do I do this? How do I do that? What's the angles? How the motion? How it moves, and so on. And again, there is no right or wrong answer. We want them to be able to participate. We want them to take a part of that lesson. And once we've been through that, okay, we take our robot from before and say, assuming this is a cheerleader, assume what should be the angle of the shoulder. Okay, the right and the left. Is this positive? Is it negative? What's the range over here? Now we want them to think. We want them to debate it. We want them to put some energy around that. And again, I mean, students type in their answers. There is no right or wrong, but the important thing is to participate. Of course, again, the teacher can see everything. And once we are done with that, it's showtime, and let's make the robot dance. So again, we have the simulated robot here. Let's just zoom in a little bit. So we have the simulated robot over here, and we can actually control the shoulder. So this is the right shoulder, and we can see the angles. That's the left shoulder. Okay, that's the left shoulder. So if you want to raise the roof, what should be the angle of each one of them? What should be the angle of the elbow, and so on. So they can actually build their dance from controlling all these angles. And that's, again, an important piece here, because we want our students to understand why angles are important. Not because the teacher said so, not because the teacher drew a triangle on the board and said that's the sum of the angles is 180. No one really cares about that. But because I want my little guy to actually dance and raise the roof. And based on that, I'll be able to do that. And again, eventually, when they're done, we want them to run the real robot. So we give them access control over the real robot, and then they can connect and run the same thing. So this is really quickly on the elementary level, where we show them, we work on geometry, on angles in around 5th, 6th grade, even 4th grade, depending on the school. And then let's jump right over to another lesson, time distance graph, more on the middle school level. And in this lesson, we will use a different robot. We'll use an autonomous car that we have as part of the program. And we'll ask them basically, what do you wonder, how autonomous cars work? By the way, we have interactive sessions here that provide answers to the students, so they don't need to wait for the teacher to provide a feedback. So we ask them, how cars measure distance, and we show them videos, and we show them how autonomous cars drive, and again we ask them, what do you wonder? Just what do you want to know? What's curious, makes you curious over here. And again, the important thing here is to participate. Once you participate, you put your your passion into that, and then the door for learning is open. And then we want you to guess again. So we have a car. It's a simulated car over here, and we have 1 meter, 100 centimeters that it needs to travel. Now we ask them if the speed of the car is 18 centimeters per second, as an example. Okay, how much time will it take before it can hit this obstacle? When does it need to stop? How do we know if we get there? And again, we want them to estimate. So just like you don't know anything. You never learned, about time distance graphs. You don't know how to use that. So just estimate. What do you think? What do you think is the right answer for that challenge? And again, no right or wrong. Just use your passion and estimate that. And eventually, when we are getting into the learning, the teacher obviously explain about the time distance calculation and so on, and they can just run their calculation. We have the variables over here, and when they're ready, they can run the simulation, and we can actually see for ourselves when the car is running, we can see if it stops by the obstacle, near the obstacle, before the obstacle, and obviously the closest you get to the obstacle, the better, because then you can can score better points or something. It's up to the teacher to create the kind of competition or something in the classroom. And then we want the students to be able to graph this data. So we said the car is traveling at a speed of 18 centimeters per second, which means that after 1 second, the car is at 18 centimeters. After 2 seconds, the car is at 36, 36 centimeters. After 3 seconds, the car is at 54 centimeters, and so on and so on. And let's just zoom out here a little bit. And then we can, start looking at the data and start to see the pattern, and then we can, introduce the equations and what does it mean, the time on the x-axis and the distance on the y-axis. What happens if we flip it, and so on. So this opens the discussion in the classroom and shows the students that, this actually represents something in the real world. And later on, when we are done with that, we take them to Scratch, and then we control the real robot, and we want the students to be able to make these robots actually travel. The real robots travel on the real, track or something, and get the measurements in the real world. And again, just like before, at the end of the lesson, we have the summary, whether you feel you mastered, and obviously the PDF that summarizes the lesson. So this is really quickly few examples of how the lessons work and how the Engage K12 uses robots in order to teach these core subjects. Thank you very much.